Hi guys, this is Vicky again, continuing with the 2015 AP Chemistry FRQ question. This is the final question, question number 7. And here we are reading, saying aluminum metal can be recycled from scrap metal by melting the metal to evaporate impurities. And A says, calculate the amount of heat needed to purify 1 mole of aluminum. Okay, originally, so T initial is 298 Kelvin by melting it. So the melting point is 933 Kelvin, aka this is T final. And the molar heat capacity of aluminum is 24 joules per mole of Kelvin. Okay, and the heat of fusion is 10.7 kilojoules per mole. Okay, so notice that heat capacity is in joules and heat of fusion is in kilojoules. Just remember that later on when you're doing the calculations to just do the conversion accordingly, okay? So A says they want you to figure out the total heat needed. So heat needed is Q equals MC delta T, right? MCAT, Q equals MCAT. So what is M? Usually it's going to be that of mass, but in this scenario we're going to be using moles because everything else they have given us, it's going to be in moles, right? So I have 1 mole. And what is the heat capacity? It's 24 joules per mole of Kelvin. And what is delta T? It's always going to be final minus initial, so 933 minus 298 Kelvin. And so Kelvin cancels out, moles cancels out, and I end up with just joules. And I end up with 15,000 joules, or if I were to convert it, it ends up being 15 kilojoules. Okie dokies. Now, from here though, it says that it has melted. So because it has melted, I am actually going to add the 15 kilojoules to the 10.7 kilojoules per mole. Okay, I just have to do that. And I end up with 26 kilojoules. Okay, so if you guys remember from like the heat capacity graph, right, we always have phase changes, right? This is solid, liquid, and gas. And it doesn't matter where you start, but if you are undergoing a phase change, which is this right here, and that happens to be heat of fusion, right? We add that. So in this scenario, we went from a particular temperature, and I guess 298 to 933. So this right here, we use the Q equals MC delta T equation, but because it melted, we also incorporate this equation, this heat to this heat, and we get the total heat needed. Okay, so that is why we add the two together. All right, B. The equation for the overall process of extracting aluminum from aluminum oxide is shown below, which requires less energy, recycling existing aluminum or extracting aluminum from aluminum oxide. Justify your answer. So from extracting aluminum from the ore, right, they gave us the equation right here, the delta H. So if I were to go back and I do the delta H calculation, the delta H was 1675 kilojoules per mole of the reaction, right? So, and if I'm looking at the reaction, I have 2 aluminums, right, per whole reaction. And that's why what I'm going to do is I'm going to actually just divide it out to just create just that 1 mole. So that's mole. And for 1 mole of the total reaction, I have 2 moles of aluminum, right? And based on this, I end up with 837.5 kilojoules per mole of aluminum. So which one is less? Okay, is 26 less than 837.5, or is it greater than? It's less. So because it's less, recycling, okay, requires less energy. Okie dokies? Super easy, right? Okay, comment below, let me know what you guys think, and I will try to create extra videos for you guys for whatever needs you guys have commented. Alright, I'll see you guys later. Bye!